Hello, welcome to this lecture. In this lecture, we would learn how to model shell and tube heat exchangers using the rigorous model, right? So this is a continuation of our simulation series. Now, from the model palette in the software, the Aspen Hysys software, you have two major heat exchangers. You have the shell and tube, and then you have the plate heat exchangers, the shell and tube and the plate. Now this, I think the plate is available from version 10 upward. You have the plate heat exchanger if you are using Aspen Hysys version 10 or any other higher version, right? So but for this particular tutorial, we are making use of the shell and tube, right? So I'll just delete this. So we'll be modeling this heat exchanger using the rigorous model, but before we get to that point, we'll start with modeling it using any of the other simple models, right? So we have our data here. Let me see. So to model rigorous heat exchangers, first you have to model it with any of the other models. Then you have to specify any heat exchanger specs that you have. Then also, after you have modeled it with the simple models, you can then switch to the rigorous model, right? And then enter your rigorous data, and then you can size the heat exchanger after you have entered all the information you have, and then you can accept the design that the software is offering to you, and that is it. That's how it works. So we'll start by modeling it with one of the simple models. Our data is here. We have our data here. So let's go back to the simulation environment. So we need to create streams for this heat exchanger. So the heat exchanger has 2 inlets and 2 outlets, right? 2 inlets and 2 outlets. So okay, before we do this, I think I want to add a pump. Yes, I want to add a valve to this quickly. I'll just quickly add a valve. So if you have been following our model, this is the model we have been working on. So you can just add a valve to your simulation after the pump, right? Our last lecture was on the pump, so you can add a valve to your pump and then specify 70 kilopascal as the pressure drop of that valve, right? So then we can now start the modeling of this heat exchanger. So the valve out is the tube side inlet to the heat exchanger. Then we can create streams for the tube side outlet and then the shell inlet and outlet. So we will just quickly do that. Now the shell inlet properties was actually given, so we'll be specifying that. That is where we'll start from. That's where we'll start this modeling from. So we will start modeling by specifying the shell inlet, right? So we have the tube inlet, the tube outlet, the shell inlet, the shell outlet. Now the shell is the hot side, right? Because it enters at a higher temperature and comes out at a lower temperature, right? So the shell side is the hot side. So we're specifying the details of this shell side, of which we have here. So this is it. So we have the temperature as Temperature is 159. Then pressure is 1170. Then STD is 55, right? 55 meter cube per hour. Then we have the composition. Okay, so we have, let me just confirm the values. Yes, N-hexane, N-pentane, I-pentane, N-pentane, I-pentane, and N-butane. So we can click OK. So we specified our shell inlet stream, right? So when you come here, you can specify the pressure drop, right? The pressure drop of both the shell and tube side, right? So you can specify that here in the parameters tab. You can specify pressure drop, right? Pressure drop. So in this case, we are going to be choosing one of the heat exchanger models, right? So you have a couple of them here, right? Our target for today is this one, the rigorous one, but we'll start with the simple weighted. Now from here you have the rigorous, you have the simple endpoint, you have the simple steady state rating, you have the simple weighted, and the dynamic rating, right? So now we are entering the we'll be entering the pressure drop of both the shell side and the tube side, right? So after entering it, it says under specified. Now you have to specify the outlet temperature of the shell side, right? The outlet temperature, of which the value is I think 121. Yes, 121.2. So we specify that 121.2. Now once you specify this, your heat exchanger is fully specified, and then it solves, right? So you have the OK message. Now you can check your the calculated parameters for your heat exchanger from performance, right? You can check the calculated parameters from performance. So you can see the duty of the exchanger, the heat loss, the heat leak, the UA, the minimum approach, the log mean temperature difference. You can find all this data from the performance tab, right? So that's for that. Then also, if you wanted to you can also add specs. You can add specs to your heat exchanger if you want. You can do that here, just like in your distillation column. You can add specs to your heat exchanger, right? So for example, if I didn't want to specify shell outlet temperature, I can go to specs and specify something else. For example, let me specify let's say LMTD. Yeah, okay, let me specify LMTD and see overall. So let me see LMTD. So now it says over specified. So for me to solve this, I need to go back to and delete this temperature, right? So once I specify LMTD and then I remove the temperature I specified, it solves back again, and then you can see the calculated values once again, right? So you see the calculated values when I specified LMTD as a specification in the design tab, right? So you see I added a new spec, and then I removed the outlet temperature that I specified initially, right? So you can actually add specs just like in your distillation column, right? So that's that for that. So we'll be moving over to the next item. So let me see. Okay, so now let's work with the rigorous model, right? So the next thing now is to work with the rigorous model. Now, for the rigorous model, what you need to do is for the rigorous model, what you need to do is go to parameters. Now, under parameters, you can simply click on size exchanger, right? Size exchanger. And in this size exchanger, you click size interactively, right? Size interactively. Now, when you click that, then you click convert. Now, when you convert it, it takes you to the rigorous model environment, right? It automatically takes you, yes, it takes you to this environment. Now, this is where you can specify details about the heat exchanger as regards geometry, right? The geometry of the heat exchanger. Then you can also specify process data as well, right? So now for this model, we are going to make use of this. Yes, we are just going to make use of this little data here, this process data here. We are going to use it to specify that particular heat exchanger that we are about to model, this one. So let me see. So we are back here. So now the thermal type is BEM, BEM, which is already specified. Then we have the tube pattern. The tube pattern is 45 rotated square. Then you have the baffle type. The baffle type is double. The baffle type is double segmental. Then you have the baffle cut orientation as vertical, right? Vertical. Then let me see. Okay, that's all. I think that's all for that first one, right? Baffle cut orientation. So that's for the geometry. Then to specify the fouling resistance, you have to go to process. You have to go to process to specify the fouling resistance. So you have hot side. Let me see. Okay, hot side fouling resistance is this. Then cold side fouling resistance is this. So that's for the fouling resistance. Yes, meter square Kelvin per watt. Okay, now the last thing to do is to specify either the hot side or the cold side temperature. It has to specify, you have to specify one of them, right? So me particularly, I specify this one, which is the hot side, right? For this particular model, where the inlet temperature, the inlet temperature of the hot side was specified, I would also specify the outlet temperature of the hot side, right? I said initially that the hot side is the shell. The shell side is the hot side, and when we were specifying the heat exchanger, we specified the temperature of the hot side. So I would also specify the outlet of that hot side, that the temperature was specified initially, right? So I will specify the outlet. The outlet calculated was 116.1, I think. So I will be specifying that instead of specifying the cold side, right? So after specifying that, I will click on size, right? So you click on size, right? At the bottom of your screen, you click on size, and then it's Hysys provides certain design options based on what you have specified. then you can choose to accept design. So you have this diagram generated for the heat exchanger based on the data you have specified. You have this, and then you have this plot as well, right? So you have this plot. So let me see. So you have all of this generated by the software after you have sized the heat exchanger. Then you can now click on accept design, right? You can click on accept design. So once you accept design, the heat exchanger will solve, right? The heat exchanger will solve. Now you can still go back and check your performance again, right? You can check your performance. If you need details of the heat exchanger, then you can go to worksheet. Now in the worksheet, you will see that the value of the shell out has changed. Now the shell out temperature has changed from, I think it was 116, right? Now it's 115. So this value was based on calculations done by the software after you have specified your rigorous data, right? After you specified your rigorous data, this value was generated, right? Now if you come over to this place, you would see that the rigorous model, the rigorous environment has been activated. Also, you would see that in the design tab too. You know that initially we used the simple weighted, right? We used the simple weighted, but now it has been converted to the rigorous shell and tube, right? The rigorous shell and tube. Let me see. Let me bring out another one and check something. Okay, so we have this. Yes, so for a heat exchanger that does not have the rigorous model activated, you will get this message in your rigorous environment. You'll be getting this message: to use this feature, choose rigorous shell and tube. You need to have EDR shell and tube installed to use this option, right? But in a case where rigorous model has been activated, this is what you would have, right? This is what you have. You'll be having all of this. Now you can also go back to the rigorous environment. You can do that by clicking here. In case you want to make some changes, you can click here and it takes you back to the rigorous environment where you can make changes to your data. You can make changes to what you initially specified, and then you can also change the process data, right? The process conditions, right? So that's it for this. Then if you need more information about your rigorous exchanger, you can use any of these tabs. They would actually give you more information about your heat exchanger, right? They will give you more information about it. So let's go back to the flow sheet, right? So we are back to the flow sheet. Delete this. So now that we are in the rigorous model, right? The rigorous model, you can still switch back to any of the simple models, right? You can switch back to any of the simple models if you want to. If you want to go back to the simple models, you can actually do that, right? You can do that by clicking. For example, you can click on simple weighted and it converts the rigorous model back to the simple weighted model, right? If you just click on it, right, it tells you this, it gives you this message and you click on yes, right? So it converts your model back to the simple weighted model or any other model you were making use of initially, right? So you see that it goes back and it tells you have to choose rigorous shell and tube to use this, right? So you can switch back and forth. So if you want to go back to your rigorous model, you can click on it. You can either go back by using the size exchanger, right? Because you have done it initially. So you can either use size exchanger, or you just click on it like this, right? And it still solves, right? It solves because you have already specified your rigorous model initially, right? So it will still solve again if you change it back to rigorous shell and tube, right? So this is how specifying the rigorous shell and tube model for heat exchangers work in Aspen Hysys. I hope you have learned something in this particular tutorial. If you still have questions on heat exchangers or heat exchanger modeling using this software, let me know in the comment section. Like this video, share with your friends. If you haven't subscribed, kindly do so, right? Thank you for joining me in this particular tutorial. Do have a good day.